Hey, hi guys. So yesterday we covered the remaining questions or queries that we had on CNN. Today we'll look at RNN. RNN briefly we have seen yesterday, but we have not got to the details in it. So there's another video that I've seen, which we'll watch again now, which actually explains RNN pretty well and also takes it to the next level kind of stuff on what is the continuation topics that we need to understand. And this definitely is a very good prerequisite for the transformer architecture and in turn the generative AI LLM models and stuff. So RNN definitely should be said that it is the first step of all those models. So the stronger we understand RNN, the better we can understand the remaining pieces part of it. Okay. So let's get started with RNN. So yeah, CET. XHని సికి ఇస్తున్నారు, ఇన్పుట్కి ఇస్తున్నారు అండ్ అవుట్పుట్కి ఇస్తున్నారు. ని సికి ఇస్తున్నారు. అవర్ల యారో మార్కులు వచ్చిందాక సికి ఇస్తున్నారు. So it's being given to CH. C is not there at all. Everything is going to H. So XH combination plus the output. All three are being packaged. So being a single value, it will become a list of values. That's the difference. Interesting, man. Very interesting. But I should look at it with an example. Both RNN, LSTM, and GRU. I should look at it with an example.
Yeah.
Oh, yeah, I think we should move on. So we didn't cover much today, not much length, but we definitely understood saying what is RNN and what is LSTM. Within RNN variants, sequence vector combinations, all combinations are possible. Sequence to sequence, sequence to vector, vector to sequence, all three combinations are possible. So those should be looked at on how they work. We should look at them with an example. Transformer encoder is nothing but a combination of uh, it's a combination of sequence to vector and sorry, sequence to vector and sequence to sequence combination kind of stuff. Both combination is where yeah, all three actually, matter of fact, is what transformer encoder network is. So sorry, encoder decoder network is not transformer. Now LSTM and GRU are where they're trying to just in the basic RNN, we are just passing the output of the previous value. But what happens over the period of time is the initial output as it goes further because of the multiplication and stuff that gets faded out and we forget it. So we should have a context, right? Especially we are dealing with sequence sentences or time series values and stuff. We should have context on what else is happening for a while, and we should remember it for some time. So how do you remember in a transactional system? If you look at it, how do you remember is you remember by caching the previous values. For example, if you are calculating for every uh, minute, every 1 minute, if you are calculating some value of a stock price or something like that, but you want to remember how it is actually growing over the period of time, so that um, you know, you still have a context of how it has grown for last 5 years, so that you could do your prediction for next minute. So we need to have that context. So how do you have the context is, the model has been trained on the 5 year data for every 1 minute. So that context needs to be set somewhere. So you should remember what is essential in this. The best is to remember everything, and the other way, we may not, remember the essential part of it. So remembrance of the previous parts plus the output of the previous part. So the combination of it, if it is there, we are having a proper prediction. So like in chat models where we have context and then you ask a question, your question is not only be answered basing on knowledge plus also the context. So that's how we answer, right? So similarly here, they're bringing in the concept of context here, which is very interesting. So, and basing on the context and the input, the output is given. So, and the implementation of it is done in LSTM and GRU. Again, we should get to the details to understand very clearly how those work. Um, so this is now I understand when I ask questions for people about transformer architecture and stuff, and attention mechanism and all that stuff. When people are saying you should actually have a very sound knowledge on the basics of RNN kind of stuff. So I went in impression saying, oh, okay, I should not hit the RNN directly. I should actually hit the whole thing from the starting. But late realization is, if you hit RNN directly, also you'll be able to understand. But nevertheless, the understanding is pretty good now with respect to ANN, CNN, now RNN. So, but we should look at examples of RNN on different types of RNN, different cells within RNN, as well as TMGRU, RNN, normal RNN cell. What are the other types of cells that are there and stuff? We should look at it. We should go through examples and give some examples and see how they really work and how they practically use RNN, what kind of vectorization or what kind of feature engineering that they do before passing it on to this neural networks kind of stuff. And of course, besides that, we should also go through coding piece part of it. But today is 11th, and I'll go on a vacation from 18th. Then I literally have 7 days to deal with this. So let's see how it goes. Okay, bye guys.